Right, so I'm Artur, and today I want to tell you about the class-free object-oriented programming. As mentioned before, it's a totally different approach to object-oriented programming, something that we haven't really done because we always work on classes, right? So, before I get to the topic, the question for all of you: who recognized this sentence? We have some people who recognize. All right. It is taken from the book called Design Patterns, and it was released in 1994. And I get the impression that over 22 years of programming, and we have learned nothing. Nothing to introduce this rule into our programming book. From my experience, 95% of the code that we used, that I have seen, uses inheritance. And basically every tutorial I ever read about new language had inheritance in one of the first chapters. And the most sad part is that most of the developers, when talking about creating new new modules, components, etc., they always talk like, okay, let's extend this and let's extend that and inherit this and inherit that. It's sad because they treat it like a default go-to almost pattern of reusing the code. And okay, but you may ask me why? Why inheritance is bad? So, the problems with inheritance. Firstly, classes tend to grow and grow, and objects tend to grow and grow. If you ever happen to work with very, very large projects in JavaScript, and they will be using classes will be huge. Other thing is that we have long inheritance chains, and this is really painful when debugging the code. Even though we have brilliant dev tools, it's very hard when you have more than, let's say, 3 or 4 levels of inheritance. So, yeah. Another problem is very small because, well, we all know that we have problems with context of the functions, right? We sometimes forget this, we forget to bind it to function, but it hurts that when we do such mistake. And the last but not least is the gorilla banana problem. And the gorilla banana problem is something like whenever I want to have a banana, I not only get the banana itself, but I also get the gorilla that holds that banana. And in the other hand, gorilla holds what? The entire jungle, right? This is what we got with inheritance, right? We always inherit everything. We cannot choose what we inherit and what not. So, people thought about this, and some came with solution, hey, let's use mixins. Why not? But I think that mixins are not the best solutions, and here's why. Firstly, we still don't have one standard how to use those mixins, how to implement them. For example, we have the standard for promises, right? We know how they should look, but we don't have this for mixins. In my opinion, mixins introduce kind of the multi-inheritance, and I consider it ugly. And sadly, mixins put more state to our components than we want to have. And this is a kind of a problem because now we're all about talking about stateless components and stateless functions and everything stateless. And mixins give us more state, right? And there's a great read about it. So I really encourage you to give it a look. So here comes the rescue. This guy, you probably know him, right? Nobody knows. Douglas Crockford, yeah? We all know him. He develops the JavaScript. He bring us the JSON format, and he is the author of JS lint, right? But probably most of you know him because of one book that he has created. And that book is obviously The Good Parts, right? And sadly, chapter 5, Inheritance. Damn. But remember that the book was published in, when it was published? 6 years ago or 7 years ago, something like that. So, and in this time, the world of JavaScript has changed very, very much. So now Crockford goes all over the world with his presentation, The Better Parts. Great, great title, right? But he, in this presentation, not only talk about new fun things in ES6 or whatever, but also he came with idea how to not use inheritance. And he called this class-free object-oriented programming. Now, in original Crockford's idea, it's very simple. So let's take a look. We start off with creating a function that is some kind of a constructor function that will return an object for us, right? And as a single argument, we give it a specification. You may think about it as a kind of a state if you're familiar to Redux or Flux, React. But it may be state, it may be specification, whatever. It's just the name. Now, we take what we need from the specification. So, for example, we take one member, another member. Then, we can compose a different object being produced by a different constructor function that works on the same specification. Okay, so far so good. We can now start implementing our own methods. So let's do it. In the example, right, I'm just doing something from that other object, but I have access here to all of the objects I compose and to all members. So I can do my logic. Just the same like in the class methods. And lastly, we return the API of the object. Now, his idea was to freeze the API so nobody will mess with our object. Yeah, it's final. The API is final. And that's it. That's the class object-oriented programming. But the idea behind it is much bigger. Because let's compare it to what we have in classical class programming. In classical programming, we have class that contains the state of an object and contains methods that can operate on that object. Now, in class-free object-oriented programming, we are forced to separating those two sets of methods or properties, right? So we get specification that contains only properties. It's a state, pure state, and we got operators that work on that state. And this leads to something like that. Our application tends to have a lot of small specifications and a lot of small stateless operators. And, well, if you think about it for a second, let's take all those specifications and put it into a big object. We can do this, right? It's easy. So it looks something like that. And if you're familiar with Redux, the data flow for React mostly, you've got the same thing. You've got one huge global state and a lot of stateless components that operate on that state. So basically, the Crockford's idea is not so different from what we already have in JavaScript. So how the reusing of the code works here? Well, it's pretty simple, right? We compose, so object, object, object. I take them all. I use them. The fun part is that I have the wrong button. I have the total API control over it, right? I pick only what I need. So I want only 2 functions from the first object, okay. And I return the API, right? So there's no way we will end up with gorilla banana problem. No way. We are in total control of what we return. So let's make a short example about it. And the example is like that. I want to have a button component. And the requirements are, it can be rendered. I can perform an action. It can perform an action when I click the button. That's why buttons are for. And on that click, I want to have some kind of animation. Let's call it a resize animation. So the button resizes. Very simple, right? So let's start. I create my constructor function, and I'm using renderable. It's some kind of abstract set of methods that allows me to render the component, right? You can think of it like a base component that you should extend in your application, right? It allows me to render. So I return the API. Okay, I can render my button. Now, I want to perform an action wherever I click the button. But I just remember that I have already a hyperlink component. Hyperlink component is a standalone component. It can be rendered on its own, but it already has action on click, right? So can I use it here? Can I compose it here? Yes. Because the hyperlink component works on the same specification, I can only take the onClick method that uses this state. And it doesn't matter whether it's a standalone component or not. I take what I need. And now I add the animation helper. It's a helper, just a set of methods that allow me to do some kind of animations. And I want to perform that animations on click. So yeah, I take the original click, I call it here, and I do my resize animation. I return only the API that I need. So I can reuse everything, basically everywhere. I can reuse the basic set of methods from kind of basic objects. I can reuse only some methods from standalone components, and I can reuse helper objects. And I'm doing it in the same way. There's no difference how I reuse it. So what I would like to tell you about are some more cool features that Class 3 brings. Firstly, does anybody heard of functional programming? Yeah, we got some people. Good. We can use Class 3 object-oriented programming in functional programming. All right. So those are two of the base assumptions. Those are not all of the assumptions of functional programming, but functions and objects should not have internal state, and all the functions should return the modified state. And this we can do very simple in our application, right? I start with passing specification. I change something in the method, and I return that specification. And basically, it's kind of a functional programming. If you would want to have it even more functional, we can move specification from here to here. And it's purely functional. Now, another great feature about it is that we have very, very easy tests, because objects are stateless. Something that is stateless is very easy to test. We just provide initial state, run the method, and check it. And we don't need, this is a really huge pain in most applications that we have to create those huge mocks of data to test something. No need for that. It looks like this. This is a simple example, right? I have value, I have some math operators that operate on this value. I do some logic, and I check whether the output is right or not wrong. But imagine a huge, complex example. It will go the same. Create state, create the component, perform logic, check. It's that easy. It does not get any more complicated. So, in conclusion, I hope you all feel a little bit excited about class 3. The good parts are, finally, we're using composition over inheritance after 22 years. We can reuse everything everywhere. We have stateless objects, which is very, very cool and very, very hip right now. We can move everything, right? We can move components and put it in different places. We have total portability. And we can use functional programming if we were not happy enough with object programming. And we have easy tests. Now, it's not a perfect solution. We never have a perfect solution, so it does have some downsides. And firstly, it is hard to use with immutable data. Although I'm not sure about it because while going here, I kind of got the idea how can do it. But yeah, it might be hard. And this is also very, very big downside. Even if you are excited with this idea and want to introduce it into your project, you have to convince everybody, including those old developers that learn, I don't know, assembly and C and C++, and tell them, no, classes no more, this is how we do it. They will not do it, never. So, yeah. Thanks. So we got questions?
Yeah, time for questions. Any questions? There is one.
I would like to ask why do you think it's... Wait.
Take the microphone.
I would like to ask, why do you think it's hard to use with immutable data? Because it kind of seems like it's perfect for it.
Not really. I mean, in my understanding of it, every time you take immutable, why I have a problem with this word? Not changing data, right? You produce a new object right here. So you cannot use the object produced by the constructor function because this specification, this state is already outdated because you returned new state.
Yeah,
right?
okay. Only if you use like this kind of creators, like the Crockford suggested. But yeah, if you like think of it about like Redux, then you can easily use with immutable data.
Yeah, probably. Yeah. So, yeah.
Just a thought. Sorry.
All right. Yeah, but that's a valid point. One more plus for class-free programming, right?
Okay, there is one question.
I have a question about this slide.
Yeah.
About the functional programming. Are you sure? Did you say that is alike functional programming, or you said that it is functional programming? Because your example here, in my understanding, when you use functional programming, there are functions that are pure, so there are no side effects, and you have side effects here in change something.
Yeah, I agree.
So it's not functional programming.
It's not entirely. Yeah, it has
definitely not
side effects, but it does not have internal state. So okay, but yeah, but as I said before, you can move the specification from the from argument here and put it here, and then you have
But
totally.
when you put it in this function and return the API, that you have to use the specs outside of your object, so it would not be your inheritance or whatever is said.
Yeah.
So it's pointless to use that with spec like argument in a function. So it's definitely not function programming, I think.
But if you, this implementation might be not entirely functional programming, but as said before, if you introduce some kind of Redux approach, then you can, and trigger an action here, then you can go totally functional.
But to sum up, I would say that it's very nice talk, and I think your idea is great, but it's not functional programming.
Nice. I might be wrong. I'm not totally functional programming, so I might be wrong.
One more question?
I have a question. In functional programming language that I learned, it was immutable by default, and you say that your thinking is troubles with, you have trouble with immutable object, immutable things.
Yeah.
And is this functional?
Well, it depends on the definition of functional programming. The definition I thought was right was that we have pure functions and we use them, and the immutable data is not core concept of the functional programming. I thought that was it, kind of an addition to the concept. At least in Redux, right? Because they tell us that this is functional, but the immutable data is not required there. So it might depend on the definition, or I might be completely wrong about it. So, yeah.
I think last question, Artur.
Okay, I have an impression. Idea of separating properties and methods.
Yeah.
I think we have it like 20 years ago in the old Turbo Pascal. Don't you think that it's reinventing the wheel back? Because
you know,
I think classes was created for something to mask the cons of this approach in, for example, Turbo Pascal. So isn't it a step back?
Well, I don't think so. I mean, show me the downsides of that separation. Tell me why Redux kind of does it this way.
Okay, if I don't have properties and methods in one class, but in separate, I can use improper methods on, I can use methods intended for other properties. Like if I have one class and I have methods in it, and I have properties, I assume that I can use every of the method from this class. But here, if I have it in the separate places, in the separate objects, I think it's a risk of using improper methods on properties.
Yeah, for example, you can have state with different name of the property, right, than you expect. So, and the method will not work on that, right?
So this is the con.
Like that. So, yeah, it might be another thing to look in this approaching. Yeah. So, yeah.
Well, end of discussions. You can. Thank you very much. Yeah.
Thanks.